Okay, so we're gonna go back and read question. Didn't I answer you?
No.
Oh, you have to go right now? Is it an emergency? Okay, you sort of have an emergency.
I'm very thirsty. You go to the bathroom
You
to
drink
do
out of the
something?
toilet.
I go to the water fountain.
That would be compatible with the fact that he's an animal.
That's true. Our dog growing up always drank out of the toilet.
Although, do parrots drink out of toilets?
Do parents?
Yeah, you called him a parrot.
I didn't even know that. That's okay.
What?
Like the bird.
Parrots or parents?
Like the bird.
Parrot.
Oh, parents, not parent.
Yeah.
You know, like if I missed something,
Not
then
parent.
I mean, I have 2 children. I've never lapped out in the toilet before. I thought maybe I wasn't following the rules.
Or have you?
Not as far as you know. Okay, so let's go back and take a look at Pythagorean Theorem. We've done that a lot, so you should be, in fact, you probably don't even need to write anything down. We're good with that?
Yeah.
My only thing about Pythagorean Theorem would be to make sure you put the values in the correct location. Remember, C is always the hypotenuse. Okay, but again, you should be by now masters of the Pythagorean Theorem. So a little bit of practice here just to make sure. Get out your calculators, by the way, so we're gonna. What we're going to look at, because I know you can all do Pythagorean Theorem, what we're going to look at is the difference between exact answers and approximate answers, because I'd like both. So solve that first triangle for x. Give me an exact answer and an approximate answer. And how many decimal places do we round the approximate answers to? 2 is correct. Oh, sorry. It's a house. Oh, okay. You're gonna make a house out of it?
Yes.
Or are you gonna do a drawing of a house? Oh, because that making a house out of that first rainstorm here. Question?
I'm trying to write like the radical sign in the calculator, but it keeps showing up as I. Like the letter I. No, I pressed. Oh wait, never mind.
Are you pressing alpha?
Yeah.
Crazy talk. Matt, what's the exact answer?
17.09.
That's the approximate answer.
Oh, the exact answer.
What was your approximate answer?
17.09.
17.09?
No.
Uh-oh.
Oh, I did 16 squared, not 15.
Oh, you're crazy. Grace, what'd you get for an approximate answer?
16.16.
16.16.
Yeah.
They like that. How about your exact answer, Grace?
329 square root 29.
3 times the square root of 29.
Yeah, that.
What was the answer before you simplified it?
Square root 261.
Square root of 261, yes?
Yes.
Okay, and so you took it through, so 9 goes into that. And then you got, say it again, 3 squared root of
Yeah.
29? Good, 3 squared root of 29. Any problems with that? X is the hypotenuse, so 6 squared plus 15 squared equals x squared. Okay, beautiful. Solve that one. Question?
My calculator died. Can I plug it in?
Certainly.
Okay, thank you.
There's a power strip there. Help yourself. Don't cost nothing. Well, it does, but you don't have to pay for it. Remember, Pythagorean theorem only works on right triangles. Did you bother to look at that right triangle, if that red triangle's right?
Yes.
Okay, good, just checking. Julia, what do you got for, let's start with the approximate.
6.32.
6.32, anybody else?
Yeah.
Yep.
We like that. And your exact answer?
2 root 10.
2 root 10. So that would be the square root of 400?
40.
No, 2 root
40.
10 would be
40.
40, yeah. Math guy. Pretty scary. Because last time I checked, 4 times 10 is 40, not 400. Good. Any problems? For some reason, I only rounded to 1 decimal place. So we know this, right?
Yeah.
Okay, just want to make sure everybody's on the same page. And again, number 1, check to make sure it's a right triangle. Number 2, make sure you're plugging the values into the right location. The 2 legs squared equals the hypotenuse squared. Okay, draw a picture, solve the problem. Let me know if you need help with any big words.
Okay, so
I know many of you probably don't have experience on ladders. But there is, well, first of all, we're going to assume that the building is perpendicular to the ground, which is safe. We're not in Pisa. And there is a, when you set up a ladder against the wall, there is a point where you don't want the base of the ladder to be too close to the wall. But obviously, there's also a point where you don't want it too far out. So there's that little happy range there. This is dealing with this just being close enough to the wall so you can reach a maximum height. Good. Got answers yet?
Yes.
Yeah. Katie, does your picture look something like this? Tell me how you labeled everything.
So, I put the 20 for the hypotenuse.
Good start, because the ladder's 20 feet long, never changes. The ladder's 20 feet. No matter where you put it, it's going to be the same length. Good.
And then I put, like 1/4 of 20 for the base. I hadn't calculated it yet.
What's 1/4 of 20?
it's 5. It's 5.
5. Okay, what'd you call this?
And then I called that X.
X. Okay, so according to the safety regulations, we cannot move the base of the ladder any closer. What would happen?
Fall back.
Fall backwards, right. The other option would be if you move it too far out and you climb the ladder, what happens?
Fall straight.
Slides down the wall, right? Which is fun to watch, by the way. I've actually been on a ladder when it slid to the side. That's kind of scary too. All right, what'd you do next, Katie?
And then so I set up the equation x squared plus 5 squared equals 20 squared.
Did you do that correctly?
Yes.
Yeah, because 20 is the hypotenuse. When you did that, what'd you get for x?
I hadn't done it yet.
19.36 feet.
Somebody confirm?
Yep.
Yeah, good. Word problem, so we want an approximate answer. Does it say? No, it doesn't say. So, but it's a word problem, so we want, You're not gonna go to a job site and say, we want that ladder to reach a height of the square root of blah, blah, blah. You're gonna do 19.36. And then don't forget units, which is feet. Okay? Any problems? Beautiful. Still easy peasy. That's what I was looking up. I had this one, the Spider-Man. By the way, the Spider-Man is unique. No matter what song you play, he'll dance to it.
Oh yeah.
Yeah.
And then I found these other two.
What do you mean?
I really doubt that'd work.
What do you mean? No matter what song you put on it, it'll appear that he's dancing to that song.
Not a slow song.
Oh, it works.
My shit.
No.
I've done it.
You know what? You know where that's
Like
from, right?
hello.
Oh, yeah.
By I don't know.
Hello by Lionel Richie?
Why?
Adele.
It's actually.
That's
Oh,
a slow
all
song.
right. You,
I know.
I don't. It's fine. I don't have it.
Oh my god.
We were making bets here.
play Hello by Adele.
Whose phone is that?
Oh, I just grabbed the right.
Oh, thank God it's not mine.
Jake's in shock.
It's his phone.
Yeah,
It's
I
not
know.
mine.
Hold on.
But mine is super.
I don't really think about it before asking that question.
Well, it works better when you plug it in. No? No. Nothing.
How about somebody sings it?
I got. Hold on. I can find it.
This is pretty lit.
I mean, Monte
Is
can
that
sing
why
it.
you had that random tab open and Google Chrome was dancing people?
Yeah, I was looking for more dancing gifts. Why did it stop playing? Oh, good.
Oh my God.
Kind of works.
See, it works.
What about like? Yeah,
What else you want?
Or All Star. It wouldn't work.
All Star?
Yeah.
Play Sweatshirt by Jacob
Who?
No, it's cool.
Sweatshirt by Jacob Sartorius.
Or is it
Clean?
Yeah.
He's like a 10-year-old. He's like a 10-year-old kid. You really think it's gonna be?
I wouldn't
dirty?
have that on my music.
I have it.
You
Google
do
it.
I said I have it.
No, not YouTube it.
If you watch the video, it's so creepy. The sweatshirt like comes alive. It's
Oh, that's really good.
It's really weird.
How'd you look it up so quick?
She had it in
Yep, see, it works.
This song is so bad.
See?
Imagine if someone just walked in right now. What are you guys doing?
We're learning.
Yeah, we're learning Jacob
Converse.
Sartorius.
So, Converse goes backwards.
Whoa.
We started with a right triangle, applied Pythagorean Theorem. Now the converse says, well, if Pythagorean Theorem works, it must be a right triangle. And we've done that before, have we not?
Yes.
Good. Let's move on, shall we? Bye. Which of those three, and it might be more than one, are right triangles? Do the calculations. No guessing, check. Question?
Yeah, so how do you know if it's a right triangle again?
Great question. Somebody want to answer that?
The two legs squared equals the hypotenuse squared.
How do you know which one's the hypotenuse, Jenna?
It's the longest side.
Good. If it is a right triangle, then the hypotenuse would be the longest side. So therefore, for instance, in the blue one, when you set it up, you would check to see if 8 squared plus 15 squared equals 17 squared.
Yeah.
Emily, does the blue one work?
Yeah.
Do we all agree?
Yeah.
Okay, where are you? Okay. Did you get feet of 10 yet.
Yeah. it doesn't
Second,
work.
second one doesn't work? Second one work?
No.
No.
The third one does.
The third one does?
Yeah.
Okay. 0.7 squared plus 2.4 squared is equal to 2.5 squared?
Yep.
Awesome. All right, so we know that the blue and the purple are right triangles. What about the green triangle then?
It's not a right triangle.
Good. What kind of triangle is it then, Matt?
Scaling.
Good. What other kind of triangle is it?
Acute.
Cute? Why? Well, it's either cute or twos, right? You got a 50-50 chance. Which one? Any particular reason? You're just guessing? Like, you get a 50-50 chance. But what we're gonna see in the next slide is we can use that setup for Pythagorean theorem to not only figure out if it's a right triangle, but also figure out is it acute or obtuse. Simon?
If what we're calling the hypotenuse, so 45, or what we thought would be the hypotenuse, if that's smaller than what 30 squared and 40 squared is, then wouldn't that be an
Hold on,
equation?
let me summarize that, hold on. I think you might, I don't know where you're going yet, but let me write that down before I lose short attention span. So you're saying if a squared plus b squared is, and I got c squared, if this is bigger than this,
Yes, then it's an obtuse triangle, isn't it?
are you asking me or telling me?
Well, both
Both.
triangles.
It's acute.
So you're suggesting this is obtuse.
It's acute.
You're saying it's acute.
Yes, because the
It's
hypotenuse is greater than.
So we don't have a consensus. You want obtuse? How many think it's obtuse? Raise your hand.
It's gonna go out on the limb.
How many think it's acute?
Oh wait,
Wow, the vote is split.
hold on.
How do we check?
No, it's obtuse.
You don't.
It's obtuse? You
Yeah.
just changed?
Yeah,
What caused you to
because
change?
I wrote it backwards because I.
Remember, alligator eats a bigger number.
Yeah.
Okay.
So a squared plus b squared equals c squared. So it's obtuse. I mean,
Wow, what
dang
an
it.
explanation.
I lost you on that one. Simon.
So in that problem, 45 should be 50 if it's a right triangle, and if that number is smaller, then wouldn't the angle be caving in?
When
Did
he
that make
said it,
sense?
Yeah.
Say that again.
Yeah.
Yeah, say that again.
So 30 squared plus 40 squared is 50 squared. Yeah.
Yeah.
And so
I don't know why I said yeah so many times. I was really excited, sorry.
so if 45 is less than 50, which it is, wouldn't the angle be caving in?
Yes.
The sides are bigger than the.
So it's not.
Right
Well,
on.
we're squaring.
Yeah, square.
I agree with Simon 100%.
Thank you.
Okay, so I forgot. What did you say this was?
Obtuse.
Obtuse. But 45 is smaller.
In that problem, that would be acute. Because c squared is less than a squared plus b squared.
So you're saying this one applies to the green.
Yes.
Are we convinced?
Yes.
Wait, no.
Uh-oh, now he's doubting himself.
No, the top one. Wait, what?
The top one.
Now he's arguing with himself. This is quite fun to watch. Hold on, can we finish it? I want to finish watching his inner turmoil. Don't start beating yourself up.
Try not to.
Okay, good.
In that problem, a squared plus b squared is greater than c squared. No, wait, what am I saying? Yeah.
Wouldn't the top one be acute because if c squared is bigger, that means that the angle is the biggest, and it would be obtuse.
Oh.
I don't know, what do you think?
I agree with Melissa.
That actually makes sense.
It's a trick.
Like because the largest angle goes with the largest side. And
Uh-huh.
so if c squared is the biggest, then it has to be obtuse because it's the biggest angle.
The c squared is
Huh.
the biggest.
Yeah.
Well, kind of going on to what Simon said a little.
Simon says.
Well, I mean, like, well, it's, I guess you said it would work if 45 was 50.
No, it would be a right triangle.
Well, yeah, it'd be a right triangle if 45 was 50. So if it's under 50, it's acute. But if it's over 50, it's obtuse.
Just been making comments.
Okay, so is this right or wrong?
I can't understand that.
It should be flipped?
The top one should be acute and the bottom one should be obtuse, because if the hypotenuse is like bigger, the biggest side, if the like legs don't add up to more than it, then it'd be obtuse, because that's like how it looks.
What's the consensus there?
I didn't understand that.
What?
I agree.
No,
She's
I think
right.
they should be
No, I
flip-flop.
agree.
Yeah.
it's
Flip?
flip.
Flip it,
Yeah.
flip it, flip it. This?
Yeah.
Yes.
Yeah.
Uh-huh.
Are you sure?
And then that's an acute triangle.
How can we be 100% sure?
Check the next slide.
What's that?
Check the next slide.
Well, but I could have written the wrong information, that would be 100%. Yeah?
You can just plug in the numbers.
What numbers? Can you give me a triangle, Jalen, that you are 100% sure is obtuse or acute? We can do either one, because if we prove one, then we got the other one.
Like with the angle measurements?
No, with the side lengths, because we need side lengths.
No. I don't think so.
So,
Well, if you add up 30 squared plus 40 squared, you get 2,500, and if you do 45 squared, it's only 2,025. And so, it would be acute if we followed those equations.
well, that's a big if. We're still not 100% sure this is correct. So let me ask a question to the group. Can anybody give me a triangle with 3 lengths that you are 100% sure is either acute or obtuse? Tommy?
Both legs are 100 and wait, it has to be a right triangle?
No, that's not what I asked.
Is any triangle that's acute or obtuse?
I need 3 sides of a triangle that you're 100% sure that that triangle is acute
Two
or
sides,
obtuse.
2 sides are 1,000, one side's 1. It'll be for sure acute because the top angle will be acute, the 2 bottoms will be acute too.
Do we agree?
I
Yes.
can't picture it in my head.
Yes.
Can't picture in your head?
I figured it.
All right,
Be-
let's move on to something different then.
No, it's acute.
It is acute
Yeah.
or is it obtuse?
If you acute.
What would it look like?
Yeah, it's like this.
Because the 2 sides
1,000,
are equal, so
1,001.
that means that the 2 bottom angles.
So it looks something
Oh,
like, whoops,
yeah,
it looks
okay.
something like, it'd look something like, yeah, wouldn't look anything like that. That?
Yeah.
And you're saying, what'd you say, 1,000, 1,001?
Yeah.
Which one goes here?
What would be the hip?
Uh-oh.
You can't because it's not a right triangle.
Oh, you could do 1,000, 1,001, and then 1.
Yeah. Or
Or,
999.
okay, wait, no, that wouldn't work because they'd be,
Wait, hold on, don't skip over that. Why wouldn't that work? That's an important point.
Because,
Why would 1,000, 1,001, and 1 not work?
because the 2 legs have to equal more than the hypotenuse.
Beautiful. Don't forget, we mixed up in all this mess is still the triangle inequality theorem where the 2 shorter sides have to add up to be greater than the third or no triangle. Go ahead.
It could be 1,000, 1,001, and like 100.
And you're sure that would be acute?
I'm not sure
Okay,
about any.
1,000, 1,001, and like 990.
Isn't that 4 sides? Alright, I'm kind of confused here.
She only gave 3 measurements.
She said 1,000, 1,001, and
No, like
900.
Yeah, 1,000, 1,001.
Oh!
That
That makes so much sense now, I'm sorry.
So is this triangle with 4 sides acute or obtuse?
Well, I mean, that's what I was confused.
I understand the confusion.
Alright.
Yeah. All right, let's simplify things a little bit here, kids.
I don't think anyone understands anymore.
Don't speak for everyone else, Maciek.
I'm a psychic. You're not a psycho. You're a psycho.
What can you tell me about that triangle?
Equilateral.
It's equilateral acute.
It's acute, right? So, how long do you want those sides to be?
Go with 4, 5. Oh, sorry, 4. Yeah.
Good, that's all, yeah, I was hoping you'd stop there, but then you just kept going. We know that's acute, yes?
Yes.
Okay, which one goes in for C?
Either one of those.
Doesn't matter. So 4 squared plus 4 squared, rectangle, 4 squared. Greater than or less than?
Greater than.
Greater than. And what do we know about this triangle?
It's acute.
It's acute. So therefore, is this right?
Yes.
It is, yes.
That was
That only took 20 minutes.
so much more complicated.
So now you're doing homework, you're taking a test, you're taking a quiz, and you can't remember which is which. If you fall back on this, it'll always work. You pick whatever you want for those side lengths. It doesn't matter. 4, 4, 4, 10, 10, 10, a gabillion, a gabillion, a gabillion. If you take 2 of the sides and square them and add them together, they're going to be bigger than the third side, which means it's an acute triangle. Don't want that dot there. Want this. Oh, by the way, we'll come back to that in the next slide. Pythagorean triples. What some of you have already noticed is that there are certain triangle lengths that always work out to be a right triangle. The two we've seen repeatedly, well, the big one we've seen repeatedly is 3, 4, 5, but 5, 12, 13 pops up. The weird thing about Pythagorean triples is it actually generates an infinite number of triangles. If you take any one of those measurements and multiply all the numbers by the same value, you'll get another triple. So for instance, Simon was talking about that triangle, it was 30, 40, and if the hypotenuse was 50, it would be a right triangle. The answer is yes, because that's a 3, 4, 5 times 10. This is not required information, this is just a time saver. If you happen to be solving the Pythagorean theorem and you realize you've got one leg is 7, one leg is 24, then boom, a triple tells you the hypotenuse has got to be 25. Oh wait, you don't remember that? No problem, just go and do Pythagorean theorem. So you're saying to yourself, what if I use the triples, how do I show work? It's real simple. If I give you 2 sides, let's say the legs are 3 and 4, and you know that the hypotenuse is a 5, then you just tell me that the hypotenuse is 5, and in parentheses you put 3, 4, 5. So you denote the triple that's being used. The other triangle we had there was 0.7, what was it, 0.7, 2.4, and 2.5. Okay. Again, finding the third side there, if you were looking for that, you get 2.5 and just put 2.5, and in parentheses you'd have 7, 24, 25. Yes, sir?
You can, oh wait, never mind.
Glad I could help. Okay. That's just 5 combinations. There are other Pythagorean triples. Those are the 5 most common that you'll see. And again, remember each one of those generates an infinite number of possibilities there, because you can multiply it by anything. A triangle with one side is of 3 million, another side of 4 million, would have a hypotenuse of 5 million. 3 halves, 4 halves, 5 halves, they all work. And again, if you don't remember the triples, that's okay. Just go back and use Pythagorean theorem, because Pythagorean theorem still applies there. That's a picture of Pythagoras.
I think that's
The statues never had, they never put eyes in the statues. Because then they could watch you.
What time was he alive? Like what
Like 12:30.
No, like
Most of the
what time
time.
period?
Oh, Pythagoras?
Yeah.
About, I think it was like 300 BC, right around there. About the same time that Euclid was kicking it. Euclid?
Who's Euclid?
I don't know who that
That's
is.
famous mathematician. He wrote all of this.
Is that what the
He wrote geometry. No, he was named after the street. Yes.
No.
My street's beautiful.
So we know that already, right? You go sit in that back corner, that's your new permanent seat. You two are acting like children. Go now. I'm tired of you guys touching each other and doing all those other weird things you're doing. Laugh it up, funny boy, get in the back
Watch it
corner.
sometime.
Don't touch anybody back there. Joey, if he touches you, feel free to stab him.
That is very weird.
Any physical contact, lash out with violence, will solve all your problems. Okay, we're done. Okay, so really the only new thing we have in there is the triples, which you've been using, we just specified it, and then the idea of using that pseudo-Pythagorean theorem to determine if it's acute or obtuse. And you recall way back in chapter 1 when we were talking about types of triangles, we never got into specifics about acute or obtuse if you were just given the side lengths. Now we can take any three sides of a triangle, number one, check to see if it's a triangle, and number two, we can now denote it as right, acute, or obtuse. Problems? This stuff, day 1, which I don't think I've unlocked yet, will actually be due on Monday because tomorrow we have the test. But you do have a good chunk of time left if you want to get started on it now.